I'm looking forward, very excited to learn about AI, just like many of you. And I'm looking forward to learning a lot from the speakers tonight about all the different aspects of engineering and machine learning that that they're going to talk about. A lot of real breakthroughs are happening in AI today that's transforming businesses, and I'm looking forward to hearing from them to see the AI today, the software AI today is not only they're creating software that doesn't do just what it's told, they are also anticipating the need of the users and customers through knowledge analysis, pattern recognition, and artificial reasoning. So the reason I put this meetup together, Practically AI, brings together leaders and innovators to explore the most promising applied machine learning and cutting-edge artificial intelligence topics. So essentially, we just want to learn more about what's happening in the industry and figure out what are different ways that machine learning can be applied in whatever field you're in. Andrew Ng said that machine learning, AI, is the electricity of the future, which means that it'll eventually power almost anything and will enable many things that weren't possible before. So I'm really excited, and I look forward to discover and learn more about AI and machine learning with all of you here. I have a wonderful set of speakers lined up, and I'm pretty sure they're going to go through a lot of things. I try to tell them to keep things high level for us, so they're not too detailed mathematical statistic, or you can always go, talk to them afterwards if you want to learn about that. But we'll keep it high level, so as people that are in the business or different field can learn to apply the different type of techniques. So we have many partners and volunteers that help us put this event together. But first of all, I would like to thank Ken, John, and Wendy and Visa for hosting this wonderful event and for providing us the meal. So let's give them a hand of applause. Thank you very much. I have a couple of partners that are here today, and I'd like to give them a couple of minutes to talk. And Rob, Ideas for IPO. Thank you.
Thanks everyone for coming and putting up with traffic. It's pretty bad. We used to do events at IBM a couple blocks away, and we stopped doing it because of traffic. But glad you guys made it. Hopefully there's more people on the way. So I organized IPO. To be blunt, it's the most active, most prolific startup event organization in Silicon Valley. Mike's one of our partners, and we're excited to be partnering with Practical AI, Mike's meetup group. We have a couple events coming up on our calendar, ideaipo.com. Next Thursday, the 31st of August, latest innovations in machine learning. We have a great panel lined up. Further on down the line, Thursday, actually it's on Wednesday, September 13th, latest innovations in robotics. That's going to be at Perkins Coie in Palo Alto. So check out all those events and all of our events on ideaipo.com. Thanks, Mike.
Next we have Tim from Jagersville. Let's give you a hand.
Thank you, everybody. So I'm Tim. I'm the video partner with Rob at IPO. I'm helping Mike out with this event, and I also cover events throughout the Bay Area. Real quick about me, got my start about 10 years ago doing weddings. Now I do a lot of corporate events, informational pieces, photography, multimedia production. So if there's anything related to that you'd like to talk about, I'm definitely someone you might want to start a conversation with later. I'll be around through the whole event. The video will be up on YouTube in a couple weeks, and I'll be around after if you'd like to talk or get info to find the video of tonight later on. So thanks again for coming, and I'll pass it back to Mike.
Thank you very much, Tim. So without further ado, I'd like to introduce Rose, which is one of our organizers. She'll be our moderator today. She'll introduce the speakers for us. So the way it's going to work is we're going to have 20 minutes for each of the speakers to talk about their topic. And let's keep all the questions until the end of their speech. And we'll have about 5 to 10 minutes, and then we'll have another transition, and then we'll go to the next speaker. All right, so we have 4 speakers lined up. So enjoy.
Rose, let's give her a hand. Thank you very much.
Hi.
Would you stand over there?
Oh, yeah.
Thank you.
Yeah, thank you everyone for coming. Welcome. So first of all, we have Dr. John Steenson. Am I?
Not doctor. Nope,
I mean,
not yet.
Mr. John. He's a senior director of information technology here at Visa Audit, I believe.
Internal audit.
Internal audit at Visa, and his interest in machine learning and AI spans over 4 decades.
Yeah.
And I believe it started from when he read the first book, which was Computation, Finite and Infinite Machines. That's when it started, and he's a proud grad of, I believe he went to University of Phoenix and specialized in technology management. And he's a recognized audit professional, thought leader, and he's on the board of directors for, how do you pronounce it? ISACA,
Yep.
the SF chapter, and he's one of the people who provides policies and stats and quality, which sets the standards for quality control. And I would love to hear from him, what he's doing here at Visa in machine learning. Thank you. Welcome.
Okay, I'm going to mic up because I tend to move around a little bit. Okay, this is an unusual topic, but one of the things that's happening in the whole AI and machine learning, and you're going to see it in regulations, is that the need for companies to be able to audit what they're doing in machine learning, how they're putting these algorithms out and making them work, is going to be subject to inquiry by government agencies. How many have heard of a regulation called GDPR? Okay, in Europe. Well, what it means is that basically your data belongs to you, and what companies do with it, they're held accountable for. And so what we're going to see is the need for you to be able to explain how you're using their data in your algorithms at the demand of those customers. And they can actually tell you to quit using their data in your business. And you have to oblige by that. And the fines are 20 million, 40 million euros. That doesn't sound like much. Or up to 4% of your annual revenue worldwide. So if you're a big company, you're looking at the potential of some very large fines. So that's why understanding when you're building these systems, give some thought to how you're going to audit them, how you're going to prove to others that these aren't introducing unintentional bias into your decisions that you're making about your customers, about certain groups of people. You've all heard about where loans are suddenly given to the people who are most creditworthy, but they're disenfranchising whole segments of the population because they want to make sure that they get paid back. And they're saying, well, it's an algorithm, we didn't do it. But some human wrote that algorithm, some human trained it. So that's what I'm going to cover today is very quickly, and I'm going to sort of burn through these slides. They're heavy slides, a lot of information. You'll have the ability to download this and look at it at your leisure, but I'm just going to sort of go through at a pretty good pace. Okay, first disclaimer, I'm not speaking for Visa. I'm speaking as an individual interested in machine learning. So lawyers like that. Okay. We're going to go through just a little bit of machine learning. And when I say as a technology, it's going to be sort of from the angle of auditing. There are a couple of exercises. We're not going to do those. They're in there. I just left them in because other people have found them useful to read through. And they pose some questions you might want to ask as you build your systems. Okay. Again, what we're trying to do is facilitate discussions. Get these, you have a whole team of people. We have a team of people. We have hundreds of people involved in machine learning and AI here at Visa. We have many, many PhDs. We have a whole research division. We take this very seriously. And we in internal audit have just in the last real 6 to 8 months started serious dialogues about how we're going to audit these applications and also how we're going to use machine learning in our auditing. It's both a plus and a minus there. Okay, and share a few examples. And really some of the areas of risk, and we'll talk about that a little bit. What's at risk if you start making bad decisions with your machine learning? And it's not just that somebody doesn't get a loan who should have gotten a loan or a fraudulent credit card transaction goes through. It can be much more serious than that. Always start out with humor. Dilbert never fails. Our machine learning technology allows us to track customer preferences and use them that use that knowledge to manipulate them. That seems like the step that happens right before the machines take over the earth and annihilate all humans. And then he says, there's always one person in every crowd who says that, and not for much long, apparently. So Scott Adams is always sort of dead on with this stuff, and he's got tongue in cheek, but there's some real truth there. Everybody knows, I'm sure if you're in this room, you've heard of Facebook basically having the machines start talking to each other in a language they didn't understand and having to pull the plug on it. And that is something that's very real. The intelligence that is being exhibited by some of these systems, they're creating new languages. They're finding out that the way we communicate isn't very efficient. They're creating their own way. But how do you provide oversight on that? How do you make sure that's working right? So they pulled the plug, plugged it back in. They're still working on it. But you've probably also seen just recently Elon Musk and a number of different people, I think there's over 100 signatories to a letter to the United States saying, let's not build autonomous weapons that can make a decision to kill humans on their own, which sounds like a pretty reasonable request.
Good, we can see now.
Maybe the machines don't like this. I don't know. Anyways. But these things are actually being built. Russia has a very active program in this area. A number of countries do, both friendly and not so friendly to us. And even if they sign it, an accord, don't do it, who bets that somebody won't be working on it? It's probably going to happen. And okay. So machine learning has a plus side, and is there somebody leaning on the lights? Yeah, let's, okay. Machine learning, and I started collecting books on machine learning, and this will give my age away, in 1967. So I've been doing this for a while, and I've enjoyed it. I've watched the transition, the 5th generation through the Japanese, all of these transitions, and now we finally have the horsepower, the algorithmic complexity, and the data to really drive this. And that's why it's changed so much. Machine learning is a science, 59. So that's really when this sort of came out and was first used as a moniker. Looking at this again, autonomous. Let me just read a few of these phrases. The field of machine learning is concerned with the question of how to construct computer programs to automatically improve with experience. Okay, true machine learning. And I want you to guess when this was written. That's what's important. In recent years, many successful machine learning applications have been developed, ranging from data mining programs to learn to detect fraudulent credit card transactions, Visa, to information filtering systems, reading preferences, well, we can go to Amazon, autonomous vehicles that learn to drive on public highways, Tesla. So, when do you think this was written? When would you guess?
90s?
90s, that's right. 1997. And when I read it for the first time, I was like, wow, driving by itself, how's that ever going to happen? Because you remember, well, some of you may or may not remember what computers were like at that time, and they didn't have the horsepower to even think about this kind of thing, or the sensory systems. Again, I won't read through all this. It just, facilitate real-time decision-making, improve actually, rapidly respond to change, lower cost. This was by Visa's Senior Director, Risk Solutions, CyberSource. We actually use all of this technology to, when you put your card through a machine, about 18,000 times a second we process that. And that includes a full trip to the bank, risk managing, risk assessing, and then coming back and saying, thumbs up, thumbs down. We do that 18,000 times a second. So that's really pretty interesting to be able to do that without machine learning and the capability and a ton of horsepower. You wouldn't be able to do that kind of thing. So look at 59, sort of first came up with machine learning. 97, now we're building programs to improve. 2016, autonomously updating its models to reflect the latest trends. You see a constant movement here about every 20 years or so, something big, 10 to 20 years. There's big jumps. In 20 years, imagine where we'll be, given what we're doing today. Who's ever seen this movie? Who's a sci-fi buff? You ever seen The Forbidden Project? Look on Netflix, watch it. It's about two computers that start talking to each other, create their own language in mathematics. Back to Facebook. And people can't understand what they're doing, but they did give them, wisely, control of their nuclear arsenals to make sure that everybody was safe. And they told them, make sure we remain safe. What's the best way to do that? Eliminate war. Well, who wars? Humans. So if I eliminate the problem, then the war doesn't happen. Go think about that one. The movie does not end on a good note. It's not one of those happy endings. But it's a great movie, 1970. Really, when I first saw it, I was like, wow, that's cool. Okay. Models are simplified approximations to the real world. And the reason this is important is you will build things that only simulate the real world. And that those simulations will embed your biases, your influences, your algorithmic strengths and weaknesses, and you're going to end up with a system that will do mostly what you want it to within the bounds that you can imagine you've put it or deployed it. But because it is a model, it's restricted in what domain it can actually work in. It's the domain you imagined you wanted to apply it to. But the world keeps changing. So again, if you're trying to look at a specific activity in a specific environment, and the world is changing at such a pace, how do you know your algorithms are still appropriate, that your training is still appropriate? How are you measuring that? You usually have a stable set of definitions, a stable set of relationships. Biology changes at a pretty slow pace, really. Not so with machine learning. This is kind of going at an incredible pace. Many models do not include well-defined operating ranges. Most people say, well, here's sort of the range I've got things in, but they don't think about what the edge case is. How could this be used? What happens if my data goes really, really out of the ranges I planned on? And how do you define risk? A risk model, in internal audit, we're always worried about risk. How do we reduce the risk to the company? We can't eliminate it. You can't move forward. You can't have a business without risk. But what you're trying to do is control that risk and manage it so that you get the benefits from it with as few of the downside aspects as you can. But you got to understand how you're talking about risk. And when you build a machine learning environment, it's got to understand what you consider acceptable risk so it doesn't run off the rails. And I won't go through all this, but again, machine learning can help reduce the likelihood of a negative event, a successful credit card fraud event, or increasing the likelihood of a positive event, a better customer support experience. So again, you have to decide, what domain am I trying to accomplish here? What am I doing with it? Machine learning is very domain specific, as we all know. We go on that one, that's bull. The one I like, I tend to do a lot of work in quantifiable risk. And so what we're trying to do now is turn, instead of low, medium, high, 1, 2, 3, 4, 5, all these artificial scales, we're trying to move to a quantifiable risk where you can say, during this period, I expect my potential loss from these category of threats to be so many dollars. Because with that, I can go talk to the CFO of the company and ask them for some money, maybe $100 million, to protect myself against $1 billion potential loss. And those are real numbers, and when we're looking at it, that's what it takes. Companies spend that kind of money. Job one at Visa is security. Got about 550 professionals dedicated to information security. That's pretty substantial investment. And most large companies have that. And most small companies are trying to figure out how they can become a large company and have that. We also look at the machine learning as both as an audit tool. How can we audit better? So we try and apply that technology for auditing, and we also use it to understand the tools that are being built by the company that use machine learning. So at the end of the day, I think where we're going to end up is we're going to have machine learning auditing machine learning. I think that's where it's going to end up. But the problem is, as auditors, I've got to turn around and audit my own machine learning algorithms to make sure that they're detecting problems in the other machine learning algorithms. So you see sort of a chicken and egg problem that's coming up, but it's not far away. We're getting there. The one nice thing is machine learning is still, at this point, a application. It's something we can generally get our arms around. But that doesn't mean it's going to stay there. How many of you have programmed in Lisp? Okay, some people, okay. But anyways, it's just, it allows you to have machines that are algorithms that change themselves, that reprogram themselves based on the way the data comes in. And a lot of machine learning does similar things, but this language was built to do that, to actually alter its very structure as it's going along. One of the foundations of auditing is I take a stable state that I know is a good one, I look at all the changes, and I get to another stable state, and I can prove that I went from point A to point B appropriately. What happens when that transition from point A to point B is done by a machine, and I can't see inside that machine? If any of you ever studied about the 5th generation projects in Japan in the 90s, a lot of those projects they took forward, we stopped, because part of the way they approached it is they didn't need, because their culture didn't demand that they be able to explain how it worked. The American culture, probably because of litigation, sort of said, you know, hey, we might get sued, we better be able to explain to somebody how this works. And so whole areas weren't pursued during that period because the potential for litigation and not being able to explain to people why this worked. Okay. Again, the data sources are growing rapidly, but when you combine data sources, how do you know you're combining them in a way that's actually workable? Anybody here have a GIS, a Geographic Information System background? Gosh, I'm striking out tonight. Anyways, I'm a cartographer, is one of the things I do also. And when you have a picture of the Earth that's in a projection, that's based like Mercator projection or something that's based in a certain way of looking at the world. And if I take a Mercator projection and another projection and try and combine them, they don't combine. But in a machine learning, it's going to think, oh, I got lats and longs and lats and longs. I'll just add those up. But they may not be projected the right way. So you have to really understand what data can I use and how do I combine it, and is it compatible? Going back to my comment about ontologies and taxonomies, you've got to have that correctly defined if you're going to take this data and blend it and use it. Otherwise, your algorithms may, again, remember what happened on Mars, meters, and the English system, feed, got messed up, and $1 billion in space junk was created because they made a mistake and they crash landed it. They thought they were coming in at a reasonable speed and they smashed up the Mars vehicle, all because of a simple misunderstanding of units. And this is anyone's reference things you can use. Again, machine learning you can play with. So any of you who haven't gotten into machine learning, literally it takes you moments to fire up an environment and play with it. And we're doing this at Visa with a lot of our auditors, is we have machine learning working groups. And just, hey, let's play with that. Let's do this. Because really you have to wallow in this stuff to really learn it. And so I encourage you, if you're not doing it, fire something up. Don't be afraid. Put your credit card in. Turn it off when you're done, because it will keep charging you. but play with it. Hardware. This to me is absolutely fascinating. I'm a hardware junkie. I started my career in writing hardware diagnostics for supercomputers. Good. I'll talk faster. And I saw what it cost to build high performance computing, Crays and that sort of thing. The Cray team, a lot of them came from our team, because we developed one of the first pipeline vector processors. But here, an NVIDIA Tesla, not the Tesla of the car, you buy this 8.73 teraflops, and the thing plugs into your desktop. That's a lot of horsepower for $4,000, under $4,000. It's amazing what you can do now. Let's see. Again, just examples of organizations auditing transactions with machine learning. I won't go through all of it because you can read it later. Audit quality, natural language processing. Again, here comparing two different techniques, artificial neural networks and expert systems, and a multiple discriminant analysis, and seeing which one will come up with a going concern. If you're an accountant, you're always worried about, hey, as I write my audit report, I have to weigh in, is this going to be a going concern or is this company on its way to failure? Well, right now they're saying, how can we do that better? And machine learning, of course, is the background of that. And for any of you that want pictures or anything, remember, all of this will be available in slides. So you don't have to take pictures if you don't want to, or if you do, that's fine. And the video will be on YouTube. So, but based on the ability of government auditors to understand what I do, see that. As a result, I sometimes have to make decisions about which algorithms are to use, not based on performance, but based on what the government auditors, us evil auditors, are going to basically tell you, you can't do that because you can't explain it. One? Okay. So anyways, can be audited, things can't be, not difficult to audit. Again, just for us auditors in the crowd, there's things that we can and can't audit easily. Doesn't mean they can't be done, but they're much more difficult. If you look at the value, though, you get from it, Deloitte has a chart here, and you see machine learning way out here in the unusual transactions identified per period. Much better for finding fraud in company transactions. So that's one of the things driving us. Don't worry about the exercises. The exercises are nice because they have some questions that you should probably be asking. Let's see. Zoom through this. Okay. The feedback loop. Really understand when you're using machine learning, how are you paying attention to what it's doing? How are you getting the feedback to know that it's on track and hasn't drifted from the purposes for which you've designed it? So again, as auditors, we're always asking those questions. Is it doing what it's supposed to do? And is it not doing what it's not supposed to do? And of course, who better to provide assurance on their accuracy than internal and external auditors? That's a plug. But it's also a plug by the Professional Association of Internal Auditors, and they're saying, hey, we already do this. Let's get to the next level. We have to deal with this. There are some things out there like Lime that will help you explain your algorithms. But if you don't incorporate that into your environment, you may or may not be able to do that. Again, why should I trust you? Understanding the reason behind predictions is quite important in assessing trust. How do you trust your model if you can't understand it and explain it to somebody else? And won't go there, won't go there. Oh, this is from Bing ad. He basically threw away his huge complex model and went to something super simple because he's tired of trying to explain it to people. And he found out, hey, this simpler model works just as well. So that's sort of a rule. Go simple if you can, because you're probably going to get about the same results. And I'll skip this example. This is an interesting example of the comment that, you know, an expected value. Well, that means something to us as humans, but to accountants, it means something completely different. And you have a right to understand that. So one of the things I say, you have a right to clarity. If you're an auditor, if you're somewhere in the company, any person in the company responsible for watching over the machine learning activities in your company, you have the right to understand how it works. And if your technicians and developers can't explain it to you, it's their fault, not yours. You need to understand that. These things are yes, they're complex, they're difficult, but you have the responsibility to manage it, so you can't walk away from that. So if you're doing a startup, think about the fact that someday you've got to explain this to your investors, why something good or bad didn't happen. Okay. Skip that, and I'm going to just sort of whip through a couple of these here. GDPR I mentioned. GDPR, few paragraphs buried in the treasure. GDPR restricts what they call automated individual decision making. So there's restrictions on it. And these are going to take over all of Europe under the EU, and they will be extended to the entire world. Everybody will have to, who wants to touch any data of a European resident, not citizen, a European resident, if you touch their data, you're subject to GDPR. Think about that. Who in the world doesn't touch European data? Anyways, there's no debate. It's going to be used more pervasively. Nothing's going to stop this. It's moving forward. And should. It's a technology that has tremendous potential. But internal auditors must be able and willing to adopt it to use it both for auditing, and we've got to be able to audit it for the businesses. There are legislative initiatives out there, the lawyers are involved, there's a lot of money to be made in suing companies over this. And you will see them come out of the woodwork in May of 2018. Why? That's when GDPR goes into effect. This 22-month, get ready period will be over, and you can bet that those regulators and lawyers are just chomping at the bit to start laying out lawsuits. So one of the things that you're going to get also is, I've told you I've been collecting books for a while. I've got 110 of my favorite books in a spreadsheet. We'll send those out, of ones I found fairly useful, and they're all available on Amazon. I've actually put the trouble looking up the links. All but one of them is still available on Amazon. Gosh, I love that. And they know what I like to watch, so they also are sending me new books on machine learning. I'm going broke. Anyways, so we'll include that also for you. Research model. And ending on a humorous note again, based on your internet history, you might be dumb enough to enjoy extreme sports. Click your ticket to base jump from the International Space Station. I think the internet is trying to kill me. Gilbert, we call it machine learning. So again, thank you so much. And are we good?
Great. Thank you so much, John. That was very, very helpful. Next, everyone, we have Dr. Shiva Kantali. If I'm pronouncing that right. He's the founder and CEO of True Shelf. It's a tech startup based in San Jose. He's taught computer science at Princeton for 4 years, and he has over 17 years of academic, industry, theoretical, and practical experience in algorithm design, complex theory, machine learning, game theory, natural language processing, information retrieval, high-performance computing, and large-scale graphic algorithms. And he's truly, truly knowledgeable, and we would love to hear from Dr. Shiva about True Shelf and what he's trying to do with that.
Yeah,
Thank you.
Thank you. Can everybody hear me? Okay, thank you for inviting me, and sorry for my voice. This is my third talk today already. So let's take a couple of quick polls. How many of you are middle school and high school students? Good. And how many of you have middle school and high school students as kids, as your son? Okay, I'm using binary search to figure out where you are. And how many of you went to middle school or high school in US? Okay, that's that. So you will relate to some of the problems that I'll be mentioning here. So this will be a very light talk where the focus is on how to improve middle school and high school education, especially math education. I'll simply give you an overview of the current status of digital learning and discuss some of the problems with the current status and propose some data-driven and AI-driven solutions. So this is the current learning model in schools, especially in USA. Students learn some concepts from their teachers and some from their tutors or parents, and they solve a limited number of problems from their textbooks. So usually they are static textbooks, and they have a fixed number of problems or examples at the end of the chapter, and they solve these problems. And after a couple of months, either they take a class test or they take some standardized test, and they get a grade. And these grades are usually at a very high level. So they get a grade, one grade for mathematics and one for physics and one for chemistry or one for SAT. One of the main problems here is they're not getting enough feedback, or they're not getting enough practice, and they don't know what their strengths are, what their weaknesses are. So let's enumerate some of the top problems with this model. So one of the topmost problems in education is this assumption that one size fits all. So when I was teaching at Princeton, my class usually has 150 students, and they all come from different backgrounds, especially at an international university like Princeton. They all come from different countries too. And they learn different topics in different models from different countries, and they all have different abilities, needs, and readiness levels. And the way we are teaching in universities and schools right now is we teach something in first week, and we give some assignments at the end of the week, and we go to the next week. And if somebody got some topics, somebody misunderstood some topics in the early weeks, they're going to misunderstand that for the rest of the semester, because they don't get enough practice on the basics, because we are too busy moving on to the next week and so on. So different students need some students need more time to practice. That's the main point here. So we're assuming one size fits all here. And the second problem is this static textbook content. So we just give them a couple of textbooks and we assume that the amount of exercises at the end of these textbooks are enough for all types of students. And in this process, they're not getting enough feedback about their strengths and weaknesses. They solve maybe 10 problems at the end of the textbooks, and after that, they really don't know what their strengths and weaknesses are. So I was talking to a high school student last month when I was giving a talk at a high school, and she's preparing for SAT. I asked her, how good are you in math? She said that I'm good in arithmetic, but I'm bad in algebra. So that's the level of information they have. But algebra is a very large topic. Within algebra, where exactly you are. So let's try to figure out. I asked her, bring me your textbook, let's figure out where you are in algebra. And she said that my school took back my algebra textbook. So that's very strange to me. They take your textbook back at the end of the school year. So they give you new textbooks for the next grade, for the next grade. Right? So when you prepare for SAT, for example, you have to figure out your algebra skills all over again. You have to figure out where you are and what you have to learn and what your strengths and weaknesses are. So that sounded very disturbing to me. So here is the status of digital learning currently. So it started with PDF files, which is essentially the digital version of textbooks. And we moved to OERs, which is Open Education Resources, and they were quite a big deal for around 10 years ago. But one of the main problems, and hundreds of millions of dollars were put in this OERs, developing these OERs. But one of the main problems here is they are not organized well. So if you want to consume content or learn mathematics using these open education resources, it's very stressful because they're all over the internet and there is no systematic way to consume the content. And then we have these online videos where professors or anybody can put a lecture online, but one of the problems with the videos is they're not interactive. Maybe you're sleeping during watching the video, right? Who's tracking you? Maybe you lost track for 30 seconds and you missed some important point there. So they are not interactive. They just don't make sure that you're active. And the third one are these ebooks, for example, Apple iBooks, where they combine videos, JavaScript animations, and PDF files. But one of the problems here is that they are not personalized, and they don't give you personalized, individualized feedback. And some edtech companies try to solve these problems, and they can be categorized into two main categories. One of them is publisher focus. So they develop machine learning and adaptive learning algorithms, and they license this technology to publishers. So, and they started around 4 or 5 years ago, and they have three main problems. One of them is they're developing and they're hiring very smart engineers to develop this adaptive learning algorithms, but they're applying those algorithms on publisher content. So publisher content is this textbooks. The textbooks that they are selling to schools, they have that in PDF formats, and they're applying these algorithms on the limited number of exercises. So even if you have smart algorithms, applying that on a small data is not helping anybody. And limited access. Only if you have that particular textbooks, if you're lucky, if your school bought that textbook, then you have access to that platform, otherwise no. And yearly reset, where they stop your login at the end of the year and you have to start over again the next year. So this is defeating the whole purpose of adaptive learning, right? So we need something that's adaptive for your lifelong learning experience. And there are some consumer-focused algorithms, but they ended up underestimating the technology that's required, and they started using wrong algorithms, and they essentially ended up building a simple round-robin fashion algorithms, just doing a round-robin and randomly generating problems. And most people found that very boring. In fact, if you talk to students, they lose interest in the first 30 minutes, saying that, okay, this is just randomly throwing problems at me. So let's try to solve these three problems in the context of mathematics education. So to solve the one-size-fits-all problem, we need some adaptivity. We need to understand the student at a very personal level and generate the content or these exercises in a very adaptive manner. And to solve the static textbook content, instead of giving them only 10 problems, we need a platform that can generate unlimited number of problems. If a student wants to learn polynomial multiplication, we can generate maybe 50 or even hundreds of problems, so that they can take their own time to understand their strengths and weaknesses and learn and solve all different examples. And the third problem is this feedback. So why don't we give continuous feedback in an interactive way at a very granular level? Instead of just saying that you're good in arithmetic, you're bad in algebra, let's give them feedback at a very granular level. I'll tell you what this granular level means. So why start with mathematics? Because mathematics is becoming very important. As we saw in the previous talk, the bar to develop these machine learning algorithms or any of the smart algorithms is getting higher. So when I was interviewing after my undergraduate studies, which was 15 years ago, they asked me very simple questions about max flow and binary search. But now undergraduate students are expected to learn what is the linear regression, what is the mathematics behind neural networks. So we have seen a big jump in the expectations from undergraduate students. And this bar is only getting higher and higher because we need more data scientists and more AI talent. And more than 80% of all the future jobs will require STEM skills, and mathematics is at the center of STEM education. And mathematics is very structured. What do I mean by that? If you look at all the skills, thousands of skills, math skills required from elementary school all the way till graduate school, we can lay out them on a piece of paper, maybe not on a piece of paper, but we can lay them out and construct this kind of directed acyclic graph, where you have some dependency between the previous skills and the advanced skills. For example, here, there is this property called distributive property, where x times 2x plus 5 is 2x squared plus 5x. That's called distributive property. So you need to understand distributive property to multiply two polynomials. So that's a dependency. And there are hundreds of skills like this. And in order to understand distributive property, you need to understand the basics of multiplication. For example, commutative property or associative property. So there's a very nice structured dependency between these skills in mathematics. So that's what we are starting with mathematics. So that's what we are developing at TrueChef. That's the startup I started a couple of years ago. In fact, I started it when I was at Princeton, where we are developing an adaptive, dynamic, and interactive platform to teach mathematics to middle school and high school students. So it's a screenshot of the platform where we are solving all these three problems. One size fits all. We have an adaptive learning platform that is truly personalized. It keeps track of what kind of mistakes you're making, what kinds of skills you're lacking. So it gives you a problem. You can select any particular topic. It generates a problem on the fly. It's not taking it from a fixed data set. It's generating on the fly. And if you solve this problem in a wrong way, it will identify what kind of mistakes you're making and what kind of skills you're lacking. And it will give you more problems to revise those skills. And if you got the problem correct, it will advance you to the next level. So that's one of the advantages. It will tell you what to do next, instead of just saying, hey, I'm done. It will tell you, if you know polynomial multiplication, let's move to matrix multiplication. So there's no limit. Some of our students who signed up, they are in 6th grade, but they're already solving 9th grade problems. So you are your own limit here. So you can go forward and to the advanced levels. TrueChef.com. I'll come back to that. So we want to understand the students at a very, very granular level and very personalized level. So here are some, apart from solving these three problems, we want to understand the students at a very personal level by identifying what kind of mistakes they're making. So here is a question: what is the volume of a sphere? The student wrote 4 by 3 pi r squared. Instead of just saying you are wrong, we want to tell them why it is pi r cubed instead of pi r squared. Right? You tell them that answer is pi r cubed, but please note that volume is 3-dimensional. So once you tell them that the volume is 3-dimensional, that there should be 3 parameters involved in the equation, then the student will never make such a mistake. Right? He'll always look at the dimensions of the solution before writing the answer. Right? So this is a conceptual mistake. We are trying to teach a concept by identifying his mistakes. Here's a second mistake where we try to give this problem x times 2x plus 5. Instead of just saying the answer is wrong, we are trying to say that this is the correct answer and we apply distributive property here. That's the second type of mistake where you don't know which property to apply. And the last but not the least are silly mistakes. X squared equal to 4, people just write x equal to 10 and move on. And so we really want to say that, okay, did you forget -2? The answer is +2 and -2. In fact, I made this mistake in my 10th grade, and you should really see my father's face on that day. I got 99 out of 100, so that's a big sin, I guess. So let's look at some of the algorithms that we are using here. Again, as I said, this is very high-level talk. I will not go through any of the specific algorithms. We have around 20 different algorithms that we use here. One of them is the mathematics engine itself that generates these math problems and also solves them and gives the solutions in step-by-step manner. And this mathematics engine is as powerful as Mathematica or MATLAB. It took us almost 4 years to develop that. And there are very specific machine learning algorithms, adaptive learning algorithms, and smooth transition algorithms. And one of the main points I want to make here is that the reason it took us 4 to 5 years to develop these algorithms is developing machine learning algorithms for recommending Netflix videos is different from developing algorithms for edtech or adaptive learning. This is where most of the startups are failing because they use out-of-the-box algorithms, random forest or whatever neural networks, and they just apply and expect it to run smoothly. In fact, there are several examples in the local high schools where they tried to use that and wasted millions of dollars. So you really have to understand the dependencies between the topics and make them very learnable. So the algorithm automatically learns these dependencies over a period of time and how much are they dependent. So there is a weight between 0 and 1 based on how frequently those dependencies occur. So it took us some time to train these systems and test them. So I want to quickly explain the space repetition algorithm. How many of you have heard this algorithm called space repetition? Okay, that's 5 minutes. Have you heard of space repetition? No. Just making sure that you didn't raise hand for both. So space repetition is a very simple concept where when you're learning a new concept, you first revise the topic very frequently every day, and once you're comfortable, you revise the topic every 3 days. Once you're more comfortable, you revise it every once a week. So as you're getting more comfortable with the topics, you increase the space between the repetitions. So that's one of the algorithms that we use, so that there's a nice balance between introducing the new topics and revising the old topics quickly. So since we released our platform around 6 months ago, we have more than 30,000 users on our platform, and more than 90% of our users log in at least 3 times a week, and they spend at least 2 hours solving 100 problems within those 2 hours. Whereas do you see a kid solving 100 problems in 2 hours, right? That's because our platform is very straightforward. There is no other noise. It's very focused and efficiently generating problems so that you can quickly solve them and move on. And teachers use the platform to get the class level statistics. They can see where the class is, what are the common mistakes the class students are making, and so that they can improve their teaching in the next class. They can focus on the most common mistakes and teach those concepts. So one of the main observations here is that students are really good at self-improvement when they're given continuous and granular feedback. That's what we noticed in the last 4 years of training and in the last 6 months of releasing it to the public. And this observation is new in education, probably new in the context of TrueShelf, but it was observed in several other areas. For example, personal fitness, business intelligence, sports, and sleep tracking. For example, sports. Sports persons are using data to improve both individual performance and the team level performance for years. How many of you have seen this movie called Moneyball? So you know what I'm talking about there, right? And how many of you use Fitbit or some kind of sleep tracking devices? And do you think they are effective? Anybody? Some, right? So one of the problems with these fitness devices is they are really good at collecting data, but they don't tell you what to do with the data. For example, when I was having insomnia problems during my PhD days, I used a sleep tracker. It's telling me that this is a high deep sleep and high sleep and so on, but I don't know what to do next, right? Maybe we should combine the data from different areas, or eating habits, lifestyle, and the fitness tracker, and then combine them and give them better correlations. That's a startup idea if you want to start. So we are bringing this proven data-driven techniques or data-driven solutions to education. So we are starting with mathematics, and soon we'll move to other areas like grammar, vocabulary. We can use natural language processing algorithms to teach grammar by generating sentences on the fly, and even programming. And we were covered in the news generously. Recently, we were featured as one of the top 10 AI companies disrupting education. Look at this URL for more information. So that's TrueShelf. So if you haven't figured out already, TrueShelf name is a combination of bookshelf and true self. So bookshelf as in a collection of smart books, and because we are trying to help students to realize their own true self in terms of learning. So that's TrueShelf. We are developing an adaptive, dynamic, and interactive platform to teach mathematics to middle school and high school students. Thank you.
Dr. Shiva, that was very, very helpful. Are you doing something with college students?
Good question. Probably a couple of years.
Yeah,
So, for example, the algorithms app is for college students.
Oh, wow, that would be nice. Thank you so much for your time. Thank you. We'll have questions like in the end. So next we have Mr. Hollis Nolan. He is the founder of Insight SoftMex Consulting. It's a startup based in San Francisco. He has a master's of data science from University of New Haven. He has a background in audio signal analysis, and his research projects have included like audio sentiment classification, recommendation engines, and customer churn prediction. And we would love to hear from Hollis how he's involved in the AI. So take it away, Hollis.
Thank you, Mike. Everyone can hear me? So thanks everyone for coming here. Thank you, Mike, for having me. I'm going to go over how AIs can track emotion and what emotion can do for businesses. Actually take action from it and have real effects. The expressions of emotion that are showing up from humans are coming out in the text they're writing. These are tweets, these are comments, these are feedback forms. And they're coming in natural language from humans, so computers have a hard time knowing what's going on. An AI algorithm is going to have to be able to understand, here's the text coming in, here's someone talking to me, interacting with Siri, is the person interacting with angry or not, and be able to adjust itself from that. Why I'm interested in this is because this is a 24th century problem. If you're familiar with Star Trek, the character Data is an android, and as John said, best to start with humor, he can't understand emotion. And here we are trying to teach computers emotion in the 21st century, and we're getting there. We're doing a pretty good job. The market size of system analysis is set to grow at 16% per year every year, and text analytics alone is 6.5 billion. So that's not even touching, to grow to 6.5 billion by 2020. That's not even touching sentiment in audio or video yet. What we're going to do today is go over 4 concrete use cases of what it can do for you and what results it can create, and then go over a brief overview of how it's implemented and how this actually looks to the IA people. So the goal of this talk is to have you be able to identify the opportunities for sentiment analysis and know what results that analysis would provide. This would enable you to put a real-world value in dollars on your next AI project. In statistics, there's a concept of lag and lead variables. Some events occur that cause or correlate with other events happening in the future. A great example of a lead variable occurring first is a court case, a CEO getting indicted. It's just a newspaper article, a bunch of words on it, but the stock price tanks a couple hours, a couple minutes afterwards. The stock price is a lag variable. And just as for you at a company, your revenue is a lag variable as well. Many things are affecting it, and you want to know ahead of time what's going to happen and make corrections as fast as possible. What this looks like in a line graph are these two lines. Let's say this is fake data. The blue line will be the sentiment of your customers, and the red line will be the revenue of the company. So an initiative or a change happening at a time point right before the first blue spike, then creates this giant, is followed by a red spike shortly afterwards in revenue. If you know that red spike is going to happen, or you're reasonably sure it's going to happen, you can have one, the website's ready for extra server time, extra people ready the phones, staff and shipping. Two, knowing that giant downturn is going to happen afterwards, you can look at how can that be avoided, what's going to happen, what's happening to create that shift, and react before it hits the revenue. So sales and revenue are lag variables, and sentiment is the lead variable. Use case one is a global score. That's what I just went over. Looks like this. In terms of just sentiment alone, this is more granular over 2 days. A global score could also show you pretty much in 15-minute increments what's happening and how people are seeing it. So if a news article just comes out, it's really great, you get that giant green spike. It's hard to see, but the positive green values are happy sentiment, and the blue values below the line are negative. Use case number, well, it should be two. Use case number two is segments. And what this can do is tell you, not only can the AI figure out how many groups of customers you have, and maybe these are just separate groups you want to target individually, you can then track them. And month to month, it can see people changing groups and actually reanalyze which customer goes into which group. This looks like a similar graph to that, except right now we're looking at just sentiment of all four groups all at the same time. And the ways this provides, one, this doesn't save costs, so when you target them individually, you can see one campaign affected the red group much more than anyone else. And two, you can see none of your campaigns affect the blue line at all. So why spend any revenue, marketing dollars towards them, or sales placing ads for them? There's having no effect. You can just save that revenue. The actual use case 3 is individual scores. This is where you look at the churn model goes through your individual customers, and it can tell you exactly which customers are most likely to leave based off of who left in the past and how long they've stayed, and different things different interactions customers had before they left. What this looks like is a ranked list. The AI algorithm, one at the very end, it's a funnel, and at the very bottom it gives you just one numerical score per customer ID. You can sort it by score and watch out for, hey, this bottom 5% of customers, gotta watch out what's happening right there. Just gonna grab my water. The fourth and final case, just as individual scores tell you who are the most likely to leave and are dangerous, they also tell you the evangelists, the customers who love you the most. And these are people who you would want to identify and provide beta access, give them a tour of your headquarters, because they're going to do your marketing for you for free. With lots of YouTubers, you give them a product, they'll make a video and get 2 million views, and they paid for the cameras, they paid for the phone microphones. Really, it can be very great for you. With those 4 use cases, are there any questions about those so far? The way to get this happen is the data science life cycle. Is how you get this project into production. And the whole part doesn't matter. We're mainly going to look at the business understanding of why you're doing it. Because all these projects start with what question are you trying to solve and what do you want to do with the answer. There's a lot of cool technology that do cool things, but you want to always start with the business understanding. After that comes understanding the data, what's coming in, and how's the machine model going to look at it. And there's several different techniques and models. There's a large variety of ways to solve the same question. When you have text data, that's tweets coming in, that's customer response forms. Machines have a lot of trouble with text. English language isn't necessarily linear. The subject could come after the verb about it. It's hierarchical. So this whole structure of characters into words and sentences and documents and into ideas. It's very hard to get a computer to understand an idea or the context. They've gotten very good at sentence level understanding now. So how machines can make sense of this? There's a variety of methods, but it all comes down to looking at individual words, what emotion that word is associated with, and what words are around it. So it turns this human problem of understanding language, what all these words mean, into a counting problem. And it looks like I'm going to be the first person, well, I'm not the first person today to show an equation, but the statistical notation is simply for every customer document, which is a customer input in text, and the class, so are they happy or not about it? What the contents of the document, and what are the most trends? So the word terrible is always associated with bad sentiment. Terrible starts getting weighted down. That's the most simple level. When you move up to a more complex model, you actually want to look at the order of language. Because I shot a photo versus I shot a person, that's completely different meanings. And working hardly versus hardly working, I don't really know the meaning of either one. So that's pushing deep learning. And when you want to look at, actually what I mentioned briefly is the context, the whole window around the words, you can give computers a larger view of what's happening, and the AI algorithm can get more nuanced response. Most of that work is done with neural networks, and you hear about deep learning. That's when these come in. I won't go in deep into the architecture here, but if you can train a neural network called an ANN, or auto encoder, it can give you as an output a position of each word in space. So it converts words into vectors. This famous paper called Word-Vec. And what that gives you is the computer has the word king, and it doesn't know what a king means, but it knows it's here in the space. If it takes, you can tell the computer to say, hey, king, subtract man. The computer does math, it comes out with queen. Without knowing what any of those concepts are, you can still manipulate them and interact with human language. Now, the computer's doing this in far more dimensions than just two, but the two-dimensional representation is really how the only way humans can interpret this. How it's built is by the skipgram method. It has this moving window that looks at 3 words of a sentence, 4 words, 5 words of a sentence. As it goes through, it actually windows through all of the text, looking at the words around each other. Just as I said, it'll give you a great knowledge of what's going on in sentences, but by the time it gets to the end of the sentence, it's forgotten what's happened at the beginning or at the start of the document. A more complex representation of the king and queen diagram is this one that won't show up in this projector at all. But I'm just going to go after that cluster in the far left with a little bit of blue in the corner. It's got the word constellation, got the word oracle, asteroid, planet, Mars. It seems pretty obvious of what concept is here. And from giving it enough words as input, enough sentences and documents as input, the computer's figured out these words are associated together, or there's a concept of astronomy and space stuff right here. Maybe asking how this relates to sentiment. Once you give a computer a sense of languages, then you give a far more nuanced version of sentiment. So rather than the binary happy, sad, you've got a whole, in this case, about 15 different sentiments, which at the very top, it's on the far right is the word pleasant, and then rotating down, pleasant, contented, serene, relaxed, subdued is right at the bottom. The far left would be sad, unpleasant, upset. So you can see which customers you're going towards. Okay, these customers just don't understand what's happening, and these customers are really frustrated, these customers are angry, something actually went wrong. And so having this algorithm go over all your customer interaction data, let you know how to target each person individually and follow up with them to address just what their needs are. So that covers a little bit of data understanding. Pretty much the model will learn itself based off just raw text input, giving it a very large amount of words. You get the input of full books to figure out what the words mean, and then give it your actual data that is that you want the sentiment scores on. Giving it full on books and moving that over is called pre-trained model. Cool. And that's it. Are there any questions? Oh, okay.
Yeah, so I would have said something like sarcasm in a language, if that's conveyed. How would it?
Missed what I'm getting at.
How would it say recognize something as a sarcasm, like somebody saying something but it actually means something else?
The question is how to recognize sarcasm, and that's still unsolved. It's completely, again, I don't know how they got data. I didn't even understand it. Okay.
Well, thank you so much. I think that was wonderful. Next we have Mr. Richard, who is the Vice President, Products and Services at People Power Company, where he leads the creation and market success of the first AI. It's a smart home security system, which is currently sold through larger service provider. He has more than 25 years experience as a technology industry executive. He's very passionate about creating remarkable customer outcomes, and he thrives on helping enterprise customer transformations. And as a product manager, he created some of the world's most iconic and commercially successful software solutions and platforms for enterprise and consumers. And previously, he was at GM, he was the VP of products, where he was the VP of products for IDT's 450 million systems division. His teams introduced the first cloud-based real-time loyalty management solutions for the world's largest casinos. Before that, he was the VP Solutions Management at Ariba. He created the SaaS procurement and business network solutions prior to that. And earlier in his career, he led product management at Oracle's database on Linux, Windows, and appliances, growing annual revenues to over $880 million. And he designed Symantec's first antivirus and security products for consumers. So there's a lot to learn from him, and so let's see what he's working on.
Well, right now we can't get the presentation. For the presentation here. Technical glitch.
We're looking forward to hearing what he has. Thank you.
Did you see this?
But I do want to throw all that stuff.
Yeah, Richard. Richard, you want to open it. It was, oh, no. No, that's John.
Into a vector mathematical model, so your AI can grab the power.
This is not it, right?
Yeah.
Yeah, the same problem.
Here you go, guys.
All right.
Okay.
Now, what was the question?
Yes. How do you translate the
that's the work.
Machine learning
There you go.
program.
I'll have you turn this thing on. I think you turn it up.
That's a pretty broad question. And without, I can't really go into any visa specific things. So that's because we do have a lot of algorithms for doing that. But in general, the ability, and remember I talked about ontologies and taxonomies and defining what things mean and how you're going to describe them. That's essential to making your machine learning learn the things you want it to do, and then also to understand the evolution of that, particularly if you're dealing in an area like fraud. You would want to know how do the fraud community change in its behavior in the things it's talking about. Because what you also have to do, besides looking at specific transactions, is you have to look at the surrounding environment. You have to be aware of what's going on in areas of sort of the deep and dark web, and you've heard all those phrases. There's a whole community of people who talk about things they're going to do, but in coded phrases. So again, you have to start extracting that and understanding that as to what that means, and that can give you some hints as to how you should be training your algorithms in preventing certain types of attacks, certain types of exposures.
So you have a team in research doing that?
Yes, we do. We have many teams. Right now we have, I think, about 200 people involved in different aspects of machine learning, from researchers to developers, and we've been doing this for a long, long time. So again, these are all public facts. I mean, our CyberSource uses risk management. We have products. If you're a bank and you want to buy our risk assessment, we'll sell it to you. Any banks here? We'll sell it to you in a minute. But this is basically, we sell these as products and we develop them as products.
Thank you.
Yeah.
Great. Well, actually, if you actually plan to release any products in Europe, you got to listen to what John said. It's really scary stuff. So, sorry for the long intro. I didn't realize that was going to be read out today. But needless to say, I've built a lot of products in the past, and I have a question. How many of you are engineers here, or consider yourself engineers? Any product managers here? A couple of them. Any founders here? Any people who want to be founders in the future? Okay, lots of folks. Actually, less than I thought. So, what I thought, you've probably been going to a lot of these meetings as I have, and every time I listen to a speaker, I pick out one or two great things. But then I always go back and say, what can I build out of that? How do I productize my great ideas? So I thought what I'd do today is spend a few minutes and talk about how you actually build an AI product. And I started out in operations research. I designed Volvo and Sony supply chain systems, and then decided not to be a programmer after that. So went into product management, but if you go to casinos today, and we talked about this a second ago, the big casinos can track your every movement, and in the hotel, based on your phone and geofencing, you downloaded the application. The minute you put in your card, they know who you are, they know how much you spent, and by the way, they also have your social security number. So guess what? They know more about you than you can imagine, what your last bet was. And if you're losing money too fast, they'll send you free spins and things like that. So Big Brother's watching you in a lot of places. But that's part of the world today, right? And one of the things that we begin to realize is that something's happening in the industry. If you look at Apple's sales over the last few years, they're losing steam. The average number of uses for a mobile application is once before someone deletes it. So there's a desire in the marketplace for something new and a new way to do things. And I think this is a really interesting point here. Between just in 12 months, the word artificial intelligence as a search item went from number 100 to 7th on the Gartner website. And what really is interesting is the fact that now you look at the way consumers are adopting AI-based type products, and we'll talk about a few later today. It's similar to the way that iPhones are now in enterprise. I don't know if any of you used the early iPhones. Corporate IT won't let you use your phone at all, right? So, no smartphones in my place. Well, guess what? Everyone's using a Samsung or an Android phone or whatever. So consumers drive basically adoption into enterprise. A new interface, if any of you is building an application today, you have to think about the invisible software. You know, people on, how many of you have an Amazon Echo at home or a Touch? A few? Get one. It's really interesting. Besides the fact that maybe, you know, Amazon might be hearing every single word in your house, right, and storing it in huge databases. It just does amazing things. In fact, almost every application today, including the one that I'm working on, can be controlled through an Amazon device, right? So something's happening in the marketplace. How many of you were around in the 1990s? You all heard of how old I am, right? So a few of you, yeah. So AI is not a new thing. It's been around for a long time. And I'm really happy to see it come back. But in the 1990s, it was a dirty word. Most of the AI solutions did not work, right? My supply chain solution for Volvo worked well some of the time it totally flopped, right? So I'm okay to say that. But basically, the reality is, you know, we have a responsibility today to really create real working solutions. And solutions that you're going to see in the marketplace are going to be life-saving. You've seen Tesla cars kill people, right? And so if you look at some of the AI solutions out there, they're starting to actually be life-critical. But, you know, the software industry is a lot like the fashion industry. Every few years, we bring back something. You know, AI came out years ago, but sometimes let's not bring back bad ideas, right? So, you know, I think that's the thing that we have to think about is learn from our mistakes. And in fact, one of the nice things that's happened is, you know, unless you're a marketing person, how many marketing people here? Aha, okay. Everyone puts AI or artificial intelligence on their product. Well, in the 50s, we realized that, hey, wait a minute, that's not really what we're doing. In the 1980s, you know, we looked at, we call it machine learning, and today if you talk to venture capitalists and you say this, they'll laugh you out of the door. You better be saying this, because that's what we're really doing today. And if you don't know the difference, you know, artificial intelligence, or true artificial intelligence, has to pass a Turing test. The Turing test says behavior has to be equivalent or indistinguishable from a human. And so far, nothing's really passed the test yet. And so machine learning is really the ability for machines to take data and learn for themselves, right? And that's actually a really sophisticated solution today. If your solution today actually does machine learning and it actually operates, you're actually pretty far ahead. But most AI tools or products today are running based on deep learning. And deep learning is really a subset of machine learning, which actually is a set of algorithms that simulate human decision making and automates things. And that's really where we are today. There are very, very few products out there that can actually get to the top. So if you think about it like the Russian doll, that's kind of what it is. You know, we're drilling down to bits, and that's really the right way to deliver solutions. So, you know, all of us want to build this, right? You know, the really great AI tool that supports humankind. But we could very easily build this, right, in the smallest way. To give you some examples of AI gone wrong, how many of you know about Microsoft Page chatbot, right? Some of you might have watched that one. It was a good one. It was out for about 16 hours, and it came up with things like Hitler was right. 9/11 was an inside job. Microsoft took it down really fast, right? And it learned from what people were saying. There were people online saying, yeah, let's get this thing to say weird shit, right? Also, the university did wiki bots. So wiki has bots that maintain things. And they did a study that found that bots are overriding each other with battles over years, right? And so you have these bots saying, oh, you wrote that. I'm going to wipe you out. So these battles go on for years, bot fights. And so I'll talk about bots later on, what a bot is. Uber ran, their cars ran 6 red lights in San Francisco, even though Uber says it was a human error. The truth is maybe the bots are learning from humans in San Francisco, right? They're running red lights. So maybe they're doing the right thing. The other one that's really cool is, you know, Twitch, you know, they put 2 Google Home devices together, and they started having a fight. And you can see it on YouTube somewhere. And basically, one bot finally said, "You're manipulating a bunch of metal." Right? So that's what the bot learned to say, and that's what the device learned to say. Hansen's robots, Sophia machine, when asked, would you kill humans? It says, okay, I will destroy humans. So, but I mean, and I think this last one is really relative to what I do today, and I'll talk about what I do today. But Virginia Tech had an Internet of Things fire. How many of you know about IoT? So I don't have to explain it. Okay, Internet of Things is all these little things inside your devices in your fridge, basically, that can talk to computers, right? But I'll go into that in a minute. But basically, the computer-controlled door caught fire and burned the whole future house down. So, you know, these things happen. In fact, how many of you have seen those Bluetooth door locks that you can buy at Home Depot? Well, go to the hacker sites. Those guys can hack them in 4 minutes. It's a fun thing for them to do. 4 minutes is all it takes to hack one of those locks. But the reality is, these appliances are here today. Every GE appliance you buy today is IoT ready. They just haven't turned it on. So you don't have a choice anymore. So for all of you that want to build AI solution builders, I thought, okay, for tonight, what could I say that, you know, the other smart guys are already saying about algorithms and so on? I'm going to talk a little bit about how you build an AI solution. I've built a few of them. First thing is, it's not that different from building any other software product or even any technology product, except for the fact that you've got just a lot more to think about. You know, you have to think about your front end. If you have a consumer product, even an enterprise product is the same. You have to think about hardware and devices, how they interact with your software. And as you know, cars can do weird things. Most AI solutions have some kind of cloud backend, especially if you use big data to do analytics. So you have lots of stuff to do there. In the gaming solution that I talked about, the average casino has 5 petabytes of data a year. So, you know, the amount of data, even for a household, that's collected from your light bulbs is huge. If you think about non-stop amount of data. And so when you build AI solutions, you really have to think about the complexity of what you're building. You know, in terms of the UI that you're going to pull in, the prescriptive analytics, you know, what are you going to do to actually start the solution? A lot of people think that an AI solution out the door works automatically, but you have to train it. It has to learn based on data. Otherwise, it's not making good decisions. And in fact, one of the first things I would recommend if you're going to launch an AI solution is start with heuristics. So I built the first semantic antivirus product. How many of you use antivirus products? So you've got a few Windows users, right? Everyone else is using Mac? Okay. But the first antivirus products had false alarms all day long until we added heuristics in there to say, hey, you know what? Just because you loaded the file over there doesn't mean it's a virus. You know, just because you put your floppy disk, you all know what floppy disks are, right? Doesn't mean that you have a virus. So, you know, starting there and then learning that maybe that's okay, upgrading the heuristics as you build up your data set, that's the way to go. And then bots is really the new application. They're very fast to build, they're very smart, and the back end is where the power resides. You're taking advantage of back-end computing in the cloud to actually drive the capabilities. And ultimately, using deep learning to fine-tune your algorithms over time. Right? If any of you is a product manager or wants to be a founder, go find this diagram. It's called an NSOC diagram. If you run this through with your team or by yourself, what it basically says is, go pick the right features that bring you to either product differentiation or be the low-cost advantage. Sorry, the monitor doesn't show it too well. But if you plot your features in this way, you realize very quickly whether you have a product for the market. You wouldn't believe how many people design a product and having gone through this exercise, and they have a bunch of features down here, none up there, or they're all down here, where there's no differentiation whatsoever, and you wonder why they're not successful. Right? So that's a little tip for you. Well, how do you build a roadmap? Well, first of all, in the AI world, you have to decide whether your solution is going to mimic a human or not, right? Because if you mimic a human, you really have to think about very different kind of behavioral things versus just controlling a machine. Right? If there's no human interface whatsoever, you have a very different product. Do you have to build an agent? Does an agent have to reside somewhere on your phone, on your IoT gateway? Does an agent collect things? And what are the boundaries for that agent to collect data? To John's point about collecting data, you're responsible for that. Someone's going to ask you one day, well, oh, hold on, what data are you collecting? Where are you storing it? I don't want it to be there anymore, right? And in fact, you want to be able to also define the boundaries. So, for example, if you're going to say, look at your car, maybe you can say road, vehicle, pedestrian signs, really bound the areas that you're going to look at. And lastly, make sure that you define the outcomes and the use cases. That's the hardest part of building an AI solution. If you haven't got all the use cases defined, I guarantee you, your solution will not work. So this is the really hard part. So go out there and learn about your problem and learn about it really, really well. And then it takes a long time to define these. So, don't start coding right away until you've got that, at least. And then the last part is defining the anchor. So in my case, it's alarms and sirens. I have to understand what's the meaning of time, right? So when you ask the user, hey, what time do you want to set your alarm? Hypothetically, they could say tomorrow. They could say 9 a.m. They could say after I wake up, right? So really different ways to answer the same question. But you as a smart developer there go, hey, I'm just going to look at what time to set, right? But if you ask the question on your Alexa, and the person says, tomorrow. Well, Alexa says, sorry, I can't understand you, right? Anyone done an Alexa certification with Amazon? Oh, that's the next pain in the behind, right? So if you want to get onto custom skills with Amazon, it's a really difficult task. So the big guys are now controlling the way we deploy AI solutions, right? So defining the data set, I'll just run along quickly here. You really have to think about how you collect your data. You have to verify the storage, and you have to make sure that you're not operating a test tube. So People Power company, the company that I work for now, we were running really big free software on the App Store for a couple of years before we even started building our solution. So we have tons of data to start. Get us up there again. And then, picking tools, depending on your budget, you can pick open source tools, or if you have a big budget, there's some really good ones that can drive your solution. Obviously, a Visa or something like that, go spend money. Heuristics, again, I talked about that early on. You have to really know your outcomes at the end of the solution you create. And then you have to collect clean data. That is the hardest part. How do you collect clean data that you can then munch and modify and then actually do your deep learning on? And then you have to introduce your AI capabilities slowly, right? So if you have a mission-critical solution, you don't automatically let your solution make decisions. You do it based on data that you collect. And then as it becomes an inherent solution for that user, they will begin to trust that it's the right thing to do. And then you can always say, hey, we did this decision based on data. And then from a product standpoint, if you're a product manager or you're a CEO, make sure you hire a really good UI person who understands human behavior if your solution has any human interaction, because that is such a critical part of the solution. And I said before, stay conservative when you make decisions, and go tell your marketing people, don't use AI, right? Because in some ways, that'll scare a lot of people away. Use words like learns, automates. The AI part, is sexy for the venture capitalists, but learns and automates is a safer word for users. And to be honest, in 10 years, the word AI will have no meaning, just like multimedia has no meaning today, right? And then have a plan B in case your AI product screws up. And then you have to decide, I'm almost done, you have to decide whether you have a web, mobile, or you go to bots, or you go straight to AI. Some people will start with building a web solution. In my case, I built all of them, so I'm up all night. Lots of work. And bots are the big thing. Go read up about bots. They're really cool. And I'll give you a little talk about people power. You can't buy a solution today in the marketplace. You can actually download it free from the App Store and Google Play. It turns your old phone into a camera, and we actually use it to learn about usage in security systems. But we actually sell our solutions to large utility providers, and you won't be able to do it in this state, but I can't say which state it is, but one state is going to actually sell it through the large utilities. When you call in and you want to change your gas, they'll sell you a security system under their name. And so, if you look at the average home, if you believe Gartner, they'll say by 2025, the average home will have 500 IoT devices. And you think about all these devices running all over your home with everyone trying to control it in every different way, it's going to be like a bot AI war. It really will be interesting. And right now, we're already seeing 100 devices in some of these places. Light bulbs. If you go to IKEA today, you can buy, light bulbs that you clap your hands and the thing goes on or off. Our solution does a bit more. We're the first home security system that learns. So, as opposed to who has like an ADT system or a security system at home, right? I had a couple of them. I always turn them off because it's annoying. I think the best thing is the sign in the yard. But the reality is, that's what happens, right? A really restrictive system that doesn't understand your behaviors, you open the back door, the police show up. Because you forgot to turn off the alarm. So, you need a smart system to learn your behavior in your home. Maybe your wife opens the window because it's hot upstairs, the police show up, right? So you really have to have something that begins to learn your lifestyle. Your dog runs around and sets up the motion sensor. Those things that you don't want to know. So like I said earlier on, we have about 1.6 million downloads. We were the #1 app 3 times in Apple Store. And we have 120 million video alerts. So we can turn your old phone into a camera, so we turn it into a zombie, basically. And you can hide it somewhere, and you can watch it. But that's just our test market. So get out there, get out of the test view, collect tons of data, and then you can drive your AI solution. So, what we try to do is add features to products that the manufacturer never imagined. So if you have a thermostat at home, one of the new thermostats out there, we can manage your energy consumption, lower your costs, but we can do it for a whole city, like we did one in a whole city in Hawaii. And then the energy company actually lowers its usage. For example, one big thing that's it's a $100 million problem in the alarm industry is a lot of the sensors, if the wind blows and it jiggles, the police show up. So, you know what I'm saying? So, if you have a home that you want to protect, a lot of people have just kind of given up. And so, our system is smart enough to know, hey, go check weather.com. What's the wind? We see a jiggle. That's not moved enough. Maybe you won't set up the alarm. Right? We will send you an email alert instead. Lights. Well, maybe you want to have lights turn on at different time in your way, or when you walk out, you have geofencing. When you walk out, basically it'll set up lights in a different part of the house. So these are things that we can automatically do for you. So that's what we are. That's an interesting area for me because it affects everybody out there. In addition to security, we also are doing managed care for older folks. So, starting to track how caregivers manage retired people at their homes, and all the things that go on in the home. And some people will say, hey, wait a minute, I don't want someone to track what's going on in my house, but, the reality is it's already happening, and we want to add value to people's lives. So, that's my thing. And the last thing I want to say is, if you're going to build a solution, make sure that your solution really helps address the skills shortage and how it can deliver faster. That should be your design mantra. So it's got to be faster, it's got to be cheaper, and it's got to be in a way that really helps mankind, I believe, right? Do good things, don't build weapons. And Casey Stengel says, if you do not know where you're going, you might end up somewhere else. And with that, I say thank you.
Any questions for all the speakers?
Which is the best bots that come
The best bot platform?
from bots?
You know, there are many out there. It depends where you are. I would look at some of the open source ones. Google's got some stuff out there. We've actually built our own because we're actually going to open up a bot shop. And I think I actually not a programmer anymore, but I actually built a bot in about 2 days. So, the code is that simple because basically it's a scripting language. And then whatever you have to do in the back end is really automated in libraries. So the reality is that's a new programming thing. You can build lots of bots really fast. Go find a language that fits what you're trying to do, right? And I think that's the key thing. So have a look out there. There's dozens. Questions about, yeah.
I had a question on one of your slides. You talked about when you're looking to develop a product, maybe you start with web or mobile or
Yes.
and then eventually AI. And it kind of struck me a little bit as like you have a collection of user interfaces and then AI, which I see is kind of potentially a foundation for what was. So I didn't really.
Yeah, so when I thought about that part, I probably didn't do a really great job on the slide. Obviously, you're building an AI solution. The question is, what is your interface going to be? Is it going to be on the web? Are you going to build a bot to drive your decision point? Are you going to build a mobile application, or are you going to do all of them? And I probably should have put AI underneath, but I think the point here is when you think about the interface for your solution, what is the interaction that you need? Is it going to be voice? Is it going to be movement? And the complexity of the solution grows dramatically with every single interface you create. So hopefully that answers that one. So sorry about the slide. But I got you thinking.
Yeah.
Great. Any more questions? I don't know how much time. Yeah. Lady over there.
Are there any industries like healthcare or finance where deep learning, for example, may not be embraced, where it might be supervised learning, or just simply the nature of the government may not be as willing to accept the black box? Right?
Sure.
Areas and self-driving cars where lives are at stake.
Right. The question was, are there any industries that might be resistant to AI?
Or deep learning.
Deep learning in general. And, if you go to the big software providers like SAP, they have deep learning and, built-in analytics, IoT into their platform. So, of course, you've got to spend millions to upgrade to their platform. So, in terms of the availability of the technology across industry, it's going to be there in the next 10 years. The question is whether you implement it. Some industries like healthcare are probably going to be slower because they have very restricted, HIPAA laws on privacy and so on. But I think there are many industries embracing like insurance. I mean, they're all about looking at actuaries and things like that. The automotive industry, autonomous cars is all over it. If you look at the acquisitions, NVIDIA, really focusing on, the car, that's the next big area. It's a done deal. Airplanes fly by themselves. The question is, today's heuristics, tomorrow could be something else. The technology is getting to be robust enough where you can actually do very simple automation very quickly. The question then is, do you need human interaction to decide whether you fly to Hawaii or you fly somewhere else? Well, the truth is, any airline pilots, the only thing they actually would do is sit there just in case it doesn't work. Right? And the big planes, like the Airbus and so on, I have friends in Singapore Airlines, they land just to keep by themselves, just to keep practicing, but the plane could fly by itself. And this is old stuff. So if you think about mission critical things, it's already happening out there. And what we have to figure out as in the tech industry is to make sure those things are really robust and safe. So for example, in my case, I never want the alarm to not go off in a house if there's an intrusion just because the bot decided to do something. So I have basically, I have a trust factor in my AI tool that I can adjust according to the safety level I want to set in there. So I have safety valves that I put in there to control how much the bot can move. And then over time, as I have big data on usage patterns, then I can adjust that, allowing the AI to be more independent. So when you build your AI product, make sure you have some control left. Don't let it run off by itself. Hopefully that answers your question. I don't think there's any industry that's not looking at this. You can read the Gartner reports. It's just, it's great on one hand. It's also a little horrific if you think there are some people building bad bots or bad AI. Last question, otherwise we're done. Any questions for any of the other speakers? Great. Well, last question.
I have a general question to all the speakers about the legal implications. The only thing I heard was GDPR, which is more the data handling piece of it. Do you see a future where AI developers sit with the legal people to say what's acceptable and what's not, or anything that's currently the law?
Well, the question is, any new legal things coming up? I'm sure the lawyers are rubbing their hands together. I mean, there's always going to be some litigation in this society. I think some of the laws for making sure that you have secure data coming into, in other words, you're not sharing data when you shouldn't be outside of what was given permission. That's happening in the United States too. I think what really needs to happen is we just have to accept the fact that whoever has the deepest pockets is going to be sued if something goes wrong. So that's our culture here and elsewhere. And maybe, John, you have a different view.
Almost every large company requires you go through a legal review of any new products, and it's for exactly those purposes. It's a risk assessment that you're doing. You say, what's the chance if we roll this product out that we're going to lose our choice because we missed something? And so I think you're right. It's not just GDPR. That's one aspect. That's about the data and how it's handled. But it also goes to how is this data used? For example, in Tesla, where the guy died, it was because somebody was doing something stupid. But they, I guess, hadn't accounted for stupid drivers, watching DVDs while they're driving down the road and missing a truck that was, should have been seen. That type of thing is going to happen continuously as we introduce this new technology. The decision on who to kill and who's going to live is going to be taken over by AI. You're driving down the street, a child steps in front of your car, and the choice for the car is run over the child or put your family into the bridge button and kill your family. Do you want to have the dial that lets you pick which one of those? And that's absolutely an important, it's being decided right now by programmers. But it's got to be decided by society in general as to, no, I want to say, I'm going to dial down and say, protect my family, and I'm sorry for the pedestrian that steps in front of me. Or I'm going to, hit after the bridge button. I don't know where the middle ground is in that one. But that's got to be decided as we deploy these solutions. There's bad effects in almost every choice you make. So, but let's address those, think about them, make conscious decisions, and then live with the litigation. Because there will be litigation no matter what you decide.
I call it natural selection, but.
Or unnatural, as the case may be.
Yeah. Thank you, everyone, for coming. Thank you to all the
Let's give everybody a speaker.
We have one announcement. You can just hear that real quick.
Hi everyone. I'm Tatiana from Silicon Valley Innovation Center. We are neighbors just across the road, across the street. So first of all, thank you for a wonderful event, Mike, and congratulations. I would like to invite those of you who are startup founders or startup team members to come to our workshop this Saturday, Building Startup Dream Team. It is free of charge. If you are interested to learn how to recruit your team, how to build your team, come to me, register, just give me your email and I will send you a promo code. And it is from 11 to 2 p.m. This Saturday in Silicon Valley Innovation Center. Is 1850 Gateway Drive. Thank you. Looking forward to it.